Hey guys, welcome back to another video. In this one, we'll be going over a TRO textbook problem covering the limiting reactant, theoretical yield, and percent yield. The problem is this one. It is problem 51 from chapter 4. And it reads that urea is a common fertilizer that is synthesized by the reaction of ammonia with carbon dioxide. It gives you the reaction, and it gives you information that a chemist combines 136.4 kilograms of ammonia with 211.4 kilograms of CO2 and obtains 168.4 kilograms of urea. Determining the limiting reactant, theoretical yield, and percent yield. So I will go and share to this screen. So this is our given information. We have our reaction. We have our, I went and searched this ahead of time, so I didn't have to look for it during the problem. The molar masses of the product or reactants products, and then we have the masses of the reactants and products that are used / produced. And so using all of this, we will start the problem. So we're looking for our limiting reactant, CO, yield, and percent yield. Okay, so first step, let's find the limiting reactant. So if we have 136.4 kilograms of NH3, and then we have to convert from kilograms to grams. And then we know that there are 17.03 grams per grams of NH3 per 1 mole of NH3. We know that for the given reaction, 2 moles of NH3 go on to produce 1 mole, 1 mole of urea. And we know that 1 mole of urea weighs or is massed at 60.06 grams of urea. I should just be writing urea out. Okay, so pulling out the calculator. 136.4. Oh wait, one last step. And then because everything else is in kilograms, we'll convert back to kilograms. 1,000 grams is 1 kilogram. And so if you do notice, we have a conversion here and here that undoes, they undo each other. And so on the next one, I just won't work that, right? It's one of those things you can notice to save yourself some time. Then if you pull out your calculator, you can go and plug in these numbers. And you get 240.5 kilograms urea. This is a bit sloppy. Side. Okay, then if you do the same thing with the CO2, we have 211.4 kilograms CO2. As I said before, I'm just going to skip this step because it'll undo itself here when we convert back. If that makes sense, I hope it does. Oh, and I forgot to write this one down. We know this is 44.01 grams per mole up here. That's the molar mass of CO2. And so we'll use that. There are 44.01 grams CO2 in 1 mole CO2. There's a 1-to-1 ratio of CO2 to urea. And then 1 mole urea is 60.06 grams. Okay, and so this gives you, if you pull out your calculator, 211.4 divided by 44.01 times 60.06, 288.5 kilograms. So looking at this, the one that produces less is the limiting reactant. And so we know that the ammonia, or this solution right here, is our limiting reactant. This is the limiting reactant. And so that's our first answer, that the ammonia is the limiting reactant. And then the next thing is, what is the theoretical yield? Well, the theoretical yield is how much ammonia would be produced. So it's 240.5 kilograms. The last question. Last question is the percent yield. And so to find percent yield, you calculate the actual yield divided by theoretical yield times 100, because we're going to percent, equals the percent yield. Okay, so we're told right here that 168.4 kilograms were produced. And we just calculated the theoretical yield to be 240.5 kilograms. We'll multiply by 100 and pulling out a calculator. 168.4 divided by 240.5 gives you about 70.02% yield urea. And so that is the answer to your percent yield question. The percent yield part of the question. The actual yield over the theoretical yield times 100% gives you your percent yield. If you guys have any questions about this, be sure to go to the discussion board and post them there. I hope you guys all have a great week. See you next time.